Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today, we're going to be looking at single and double displacement reactions. And so we kind of already used our solubility chart, and we're going to be using it again. But the first thing that we need to talk about is a term that I used when we were looking at your solubility chart that I never really defined. And so that would be the term precipitate. So precipitate or precipitate is a solid that forms as a product in a chemical reaction. So when you mix two aqueous solutions together, occasionally what you will get is a solid forming, and we call that a precipitate. So here's an example of lead-2 iodide. So one of these solutions has lead-2 ions floating around in it. One of these clear solutions has iodide ions floating around in it. When you mix them together, the lead-2 and the iodide form this nice, weird kind of yellow color. And so you're making a solid. If you look up the solubility of lead-2 iodide, it says lead-2 iodide doesn't dissolve in water. And so when you mix them together, even though the ions themselves might dissolve in water, when you mix them together, you get this solid forming. And so that would be an example of a precipitate. And so like it says, double and single displacement reactions can form things like precipitates. So how can you tell if a reaction is going to form a precipitate or not? Well, in double displacement reactions, if the product is insoluble, so if you are mixing two things together and you get a product that's insoluble, that is your precipitate. If all of the products are soluble, then no reaction happened. So let's take a look at these, right? It says predict whether a product is going to have a precipitate or not using your solubility chart. So it doesn't matter about this part, okay? All we care about are the products here. So you can see these are aqueous solutions. I can put this in a dropper bottle, I can put this in a dropper bottle, and I can mix them together in a test tube. And what I'm gonna make are these, but we wanna know whether or not, are these soluble or insoluble in water? So if they're all soluble in water, nothing's going to happen. So even though I mix these two things together and it looks like a chemical reactions might happen, if they're all AQ, then nothing happened, and I didn't actually have a chemical reaction occur at all. And so sometimes that happens. Sometimes you mix two chemicals together and nothing happens, and so no chemical reaction occurred. But in some cases, it does happen. So we need to know whether these are going to be S's or AQs. So just like these are all AQs, we want to know how many of these are going to be S's and AQs. So look up this, okay? I've got copper 2 nitrate. Look up copper 2 nitrate on your solubility chart. Okay, that is aqueous. What about silver chloride? That is a solid. So guess what? This actually happens. This is a reaction. If I mix these two things together, I'm going to be making this. And so AgCl is your precipitate. What about this? Okay, I've got lithium carbonate, I've got barium chloride. It doesn't matter though, because again, these are just aqueous solutions, but I want to know whether these are aqueous or whether they're solids. So I've got lithium chloride, look it up on your solubility chart. Aqueous. What about this? Barium carbonate. Solid. So this is also a chemical reaction. If I were to mix these two things together, I would make this solid. And so barium carbonate is my precipitate. What about this? I've got sodium chloride and I've got lithium nitrate. I mix them together. I get sodium nitrate. That's aqueous. I get lithium chloride. That's aqueous. Guess what? When I put them together, I get no reaction. So if I were to mix salt solution or salt water solution with a lithium nitrate solution, you might think, oh, hey, look, I made these, it's a double displacement reaction. I made these. But in reality, this entire thing isn't a chemical reaction. All right. Let's try single displacement. So in a single displacement, remember that what's happening is you are forming metals in some way, or you're forming hydrogen. Okay, hydrogen being H2, that's it. So like it says, in single displacement reactions, you have one metal, or hydrogen, replacing something in a chemical reaction. And so what you get is a metal or hydrogen as a result. Not every metal, though, is allowed to replace another. In fact, there is a list of metals called the activity series that lets us know whether or not a metal can be replaced by another metal. So what is the rule for the activity series? The rule is a metal higher on the activity series can always replace a metal lower on the activity series. And if a metal that's lower tries to replace a metal that's higher, nothing happens. What does the activity series look like? Well, thankfully, you're given the activity series. Okay, you don't have to memorize them or anything. You're given on your formula page a copy of the activity series. So here's what it looks like. Notice we have lithium, rubidium, potassium, barium, calcium. So we have like a lot of plus ones right here. Then we're going more into like the transition metals here. Yes, we have hydrogen. And then look at these transition metals. These transition metals are kind of the valuable ones. You've got silver, platinum, gold. Yeah, mercury's there too. But still, and you've got copper. You got the more expensive ones a little bit further down. So taking a look at that chart, I want to know, is a reaction going to happen or not if I mix these together? So remember, single displacement reactions, this would be my metal, zinc. It's trying to replace copper. Is zinc able to replace copper according to the activity series? Correct answer. Yes. Zinc is able to replace copper. So what I would get as a result of that, think about it, zinc is pushing copper out of the way. Now copper is all by itself, so I would actually make copper in this reaction. And these reactions are really cool looking. What about this? Okay, I've got Mg, so that's magnesium. I've got Na, I've got sodium here. Is magnesium able to replace sodium? Is that allowed? Correct answer. No, it is not allowed. Magnesium can't replace sodium. Okay, it's forbidden because of the activity series. Remember, something higher can replace something lower, not vice versa. What about this? I've got iron and I've got silver. Is iron able to replace silver? Yes, it is. And in fact, like it says right here, I would end up making right here, I've got my nice solid silver. So that's pretty much it. If you have any questions, let me know.